focus groups. The first focus group is to address some of the main open issues like the jobs, the skill management and enhancements, and HR recruiting and all those things. Another focus group, which is very important for us to understand, the reason why I'm laying out this structure is for going forward how our team is going to operate, inshallah. So the second focus group we talked about, we thought about it's like an AI core engineering team, which is going to present today's session like transformers and LLMs, other details. And the third final group, which we thought, inshallah, going to be beneficial for the community is the entrepreneurship and how we are going to do some startups and funding from the VCs. That's the idea. So today's, inshallah, and this is our 2025 program going forward. Every month we have come back. Now, instead of doing quarterly, we said it's not going to work. Quarterly is too long because the AI, how the fast it's moving. So we said every month we'll start the program here. All events will be monthly basis. So some of them are kind of very exciting. If you see the December one is going to be open for everybody. But before that, we are trying to prep the community, inshallah, with some demos, with somebody coming from the outside, and from the community itself, with their own products, with their own startups. So with that, inshallah ta'ala, we have 9:30 is our Isha prayer, so we want to close just before that, so that for people to review the wudu. And if time permits, we'll try to close all the sections. In case if we have to continue and have some question and answers, we'll see if we have to come back after Isha. But till that, I will hand over this to Raza Bhai, and inshallah from here he's going to do some all navigation, inshallah. Jazakallah khair.
Assalamu alaikum everyone. So as Saeed Bhai was telling you that we have got a packed schedule today, and I am going to be just giving you a top level introduction about transformers, the model or the neural network architecture that has started the revolution of large language models. This is my background. I have been fortunate and blessed to be part of a few big tech companies and quite a few good institutes as well. I'm not going to go into the detail of my background, but I can talk about my experience later on. I want to go right ahead and jump into the transformers architecture. And one of the challenge in this presentation is that I want to take care of the diverse background of the audience, and it is really hard to take care of all of the technical details because different people, some of the people may already be well aware of the transformer architecture, some may be starting, and some may be coming from a different background. So it is going to be a very top level or high level overview of transformers, so bear with me if I am not going into a lot of technical details. At the same time, the aim or focus is not to go into a lot of mathematical or technical stuff. The aim is to just give you an overview or intuition that how this particular architecture came into existence, what was the motivation, what was the intuition, and how, or what are some of the things that you can carry even if you are not very if you are not having a background in AI, or if you are not using it in your day-to-day job. So let's get started. So the transformer is a neural network model, and it was originally used in natural language processing tasks. And one of the core component of the transformer model is that it uses attention mechanisms to process sequential data. We are going to go into some of the details of these concepts that I mentioned, but the reason that we are going into or starting with the transformer architecture is that most of the popular large language models that we are seeing in the outside, or what you may have already been using, models like GPT series of models, Claude, Anthropic Claude models, Google Gemini, Grok, they have been using the transformer architecture in one way or the other. They have got some optimizations. Many times these optimizations are related to data or some training recipes, but at the core, the transformer architecture is there in some form. So we thought that it is going to be advantageous for the audience to get to know some of the concepts that were there in the transformer architecture, and maybe some of you can take this forward and extend this architecture, use this architecture in your day-to-day work. So that was the motivation. One other thing that I want to highlight over here is that originally the transformer model was more focused on the textual data, sequential text data, but it has been extended to other forms or modalities as well. For example, it has been used for images data as well, and then graphs data as well. And so last thing before we get into the details, the architecture that I am going to describe is from the GPT-1, and since then there have been a lot of developments and improvements in the industry. As a matter of fact, some of these companies have stopped sharing the technical details of their models as well. So I may not have all of the knowledge that what is going to be inside in ChatGPT models or latest Gemini models, but as I was saying, that the transformer model is has influenced quite some models that have came after the GPT-1 model. So let's get started. So we have been talking about large language models, and we should know that what is exactly a large language model, because it is going to give us the motivation that why different things are there in the transformer architecture. So first of all, the language model is simply a model that can predict the probability of sequence of words. Or in other words, given a current sequence of words, can we predict that what is the most likely next word? And this particular model is very successful in quite a few different downstream tasks. And I think that all of you would have seen one particular application of language models. Whenever you are typing something in Google search starts giving you some recommendation to autocomplete your sentence. That is like a very classical application of large language models and large language models. But the applications are not only restricted to autocompletion. As a matter of fact, the transformer or language models have become the starting point of all the machine learning products right now. As a matter of fact, in industry, we are seeing sort of a third or fourth wave of machine learning based models where everything right now is based on transformer or large language models. So as we were discussing that transformer is a neural network model. So before I go into the detail, I just want to give you a top level overview of some of the concepts like neural networks to start with. So neural network is simply a architecture or computational unit that is going to apply a particular function to a weighted combination of inputs. In other words, there are going to be multiple inputs to each of the neuron, and then the neural network is going to apply a function which is called as the activation function as well. And on the basis of the activation function, it is either going to have a 0-1 output, which is the case in this particular activation function that is shown on the screen, or it can have some other output as well. Neural networks work in two steps or two phases. In the forward pass, they just apply the activation function on the input that is given to us. So they multiply the input with the weights, and then they apply the activation function and give you the output. And based on the output during the training phase, we determine the extent of error. And that error is propagated back so that we can update the weights. And that is called as the backward pass as well. So in other words, every time when you are going to be training a neural network model, you are going to be determining the errors. On the basis of errors, you are going to be updating different weights in different dimensions, and the extent to which each weight is going to get updated depends upon its contribution in the error. That is like a very top level overview of neural networks. One important takeaway from this slide is that neural networks can work to extract nonlinear trend or complex trends only if they are using these nonlinear activation function. Just like we had this nonlinear elbow shape function shown on the screen. So that particular function is important. If we are only going to be having only linear functions, then it is only going to be learning linear trends, which is not going to be helpful in many complex cases. So takeaway one, this non-linearity is very important whenever we are talking about determining or learning complex patterns. Second thing, over the years, scientists and practitioners have seen this thing that we can stack neural networks. We can have multiple layers. And this was exactly the trend back in 2016, 2017, when we used to have the deep learning as a big field. So machine learning back then used to be called as deep learning. So we used to have very deep networks where neural networks were stacked on top of each other, and they used to perform different type of actions. So the second takeaway that I want you to take away from neural network related concept is that we can stack neural network layers on top of it, and it can be very helpful in many different cases. So coming back to the language models, we are interested in predicting the next word. So given the concept that I have described to you, let's suppose that the input sentence was the student opened there. And now we want to predict the next word. So one thing we can do is that we can have a windowed approach. By windowed approach, we are going to, let's say, if the window size is 4, we are going to take the first 4 tokens, we are going to feed it into a neural network, and then we are going to apply some processing activation function and other recipes, and then we are going to finally get our output. But the problem in this particular case is going to be that we will have to specify the length of the input. And even if we extend the length of the input, then every token or every input word is going to be having a separate weight matrix, which is not going to be helpful. It is not going to be scalable. So, another thing, that language is a very sequential thing. So if we have got some order of some information about the order of the input, that is going to be very, very helpful or useful when we are trying to predict the next word. So these things cannot be handled by this fixed window neural language model. So as the next step, what scientists came up was this recurrent neural network. So in recurrent neural networks, instead of only having this particular window and not passing any information between different units, so we are going to have a recurrence involved over here. And by recurrence, I mean that at every step, we are going to be passing the information from the previous neuron as well, in addition to the weight matrices that we were already learning using in the vanilla neural networks. So this is what recurrent neural networks mean. So these techniques were very, very helpful. As a matter of fact, these were the state-of-the-art models back around 2015, 2016. But one other problem with them was that they had a memory bottleneck. Or in other words, if you are having a long sentence, so all of the information from the start of the sentence needs to be carried to the end of the sentence before it can be translated or before it can be processed in any way. So this is like a memory bottleneck. It is also called as long-term memory problem, that if there is a sentence and if there is a long sentence and to answer the question correctly, you need to know the information at the start of the sentence. So these particular neural network models had this problem that they cannot focus or attend to something that was at the start of the sentence, specifically if the sentences are very long. So this was the problem with the models around 2015, 2016, recurrent neural networks, LSTM and others. And to handle these problems, the attention mechanism was coined. And attention mechanism is a very simple mechanism. So basically what attention does is that it follows some of the concepts that we may already be familiar in databases or hashing, that we are going to have an input query. We are going to try to find the closest key corresponding to that particular query, and then we are going to retrieve the value associated with that particular key. And in addition to only retrieving or returning only one value, rather we are going to have a weighted combination of query and key similarity. This is attention. Or what it is solving is that instead of relying on information or context at the last neuron in the input, we can look at all of the previous neurons or all of the previous tokens in the context, and we can see that which neuron should contribute more or which input token should contribute more as compared to the other tokens. And this is called the attention mechanism. So attention is a very intuitive mechanism. Let's suppose that we are reading a book and we have got a paragraph of, let's say, 500 words. And we want to answer something on the basis of that particular paragraph. So we obviously know whenever we are reading a paragraph, we know that some of the concepts can be there at the end of the paragraph, some of the concepts can be there at the start of the paragraph. But if we have to answer the question correctly, we should be able to look back at all of the points in our memory or all of the words. And this is effectively what attention is doing. And this is the magic piece behind the transformer architecture or the large language models, which has proven to be very, very successful. So this was all it about the background. Now I'm going to just describe that how these concepts were incorporated into the GPT-1 model. And as I was explaining early, so this is only the GPT-1 model. Now we are talking about GPT-5. So many things have changed, but some of the concepts still remain there. So first of all, we are talking about a sequence of n words, and we want to predict the next word. And we want, when we talk about predicting the next word, we are just associating the probability that what is going to be the most likely word after this current input. In other words, we have got the fixed input vocabulary and the fixed output vocabulary, and we are associating a probability with all of the tokens in the vocabulary, and the token that is going to be having the highest probability, that is going to be selected or predicted as the next step. One problem over here is that, or maybe a concept over here, not a problem, that computers cannot understand the words or English directly. So we have to encode them somehow. And one way to encode them can be that we can have something which is called as the one-hot vector as well. By one-hot vector, I mean that there is going to be a vector of fixed length, and then only one of the entry is going to be having one, and that particular entry is going to be an indication of which word is it. For example, we can decide that we are going to represent the word by this particular vector. But the problem with this particular approach is that we are going to have very sparse representation. In other words, we are going to have huge matrices, but in each of the row only one particular entry is going to be set. And the way to handle this thing is to use the distributed representation or the embeddings as well. So what embeddings do is that they are going to have a distributed representation of each of the words in the vocabulary, and the words that are close to each other are going to have similar representation. And by similarity, I mean that they are going to have the bits turned on, or the just like we have got one indicated with dotted circles over here. So if there are two rows which have got similar positions turned on, then this is an indication that these are very similar words to each other. So for example, king and monarchs are going to have similar representation. So this is what embedding does. And another advantage of embedding is that we are going to have much smaller representation. We are not going to be wasting a lot of memory. And the reason that we are talking about this thing is that this is the starting point of these large language models or GPT models, that they convert the input into embeddings, and then they also do some additional stuff in the embedding layer, and that is that they encode the position related information as well. So this is the first step. At the first step in these large language models, the input data is passed through an embedding layer. Some positional information is added to the input embedding as well. Next thing is that these large language models use multiple blocks or layers of masked multi-self attention. And there are different type of attention, as we are talking about only the GPT model, which is actually a decoder only model, which I am going to come back towards the end of the presentation. But just bear with me for a while that we are going to be having the input embedding layer, then multiple attention layers. And then as there are masked multi-self attention, self-attention means that we are going to be attending to different tokens in the input that has already been generated. So we are going to be looking backward towards what we have already predicted in the current sequence. That is what we mean by self-attention. Second thing, we are talking about mass self-attention. Mass simply means that we are not going to be attending at some positions because the output at those positions has not been generated. And last thing, we are going to be using multi-attention, which means that we are going to have multiple attention units performing this step, or in other words, we are going to have internally multiple query, key and value pairs that are going to be extracting different patterns or information from the input that we have. So that is the second layer of the transformer architecture. Over here we are showing it as masked multi-head self-attention. So as I was talking about the neural networks earlier on, one thing we discussed that we need to have non-linearities. And by non-linearities, I mean that we need to insert non-linearities in our learning process somehow, because otherwise we are only going to be learning linear trends. And that is a simple thing. We can simply add some feed-forward layers or some sort of non-linear units that are going to take the input, apply some non-linearity, and then give us the output. And that is shown as the feed-forward components over here. And then we do some additional tricks, that layer normalization, which means that we are going to make sure that the average and standard deviation of the input at each layer is the same, and we are having some additional residual connection as well. So overall, all of this leads to this particular architecture. We start with the embedding layer. We have masked multi-head, masked multi-self-attention. We have got layer normalization. We have got skip connection, which are shown by the orange skip lines in the picture over here. And then we are having some non-linearity through the feed-forward layers, and again we are having layer normalization. And we can use this particular model to do different type of tasks, text prediction or text classification. So this is the overall architecture of the GPT-1, and this particular architecture, coupled with some sophisticated training schemes, a lot of training data, has led to GPT-2, GPT-3, GPT-4 and GPT-5 models, which maybe we are going to cover in the future sessions. But this was the transformer architecture. One other thing that I wanted to highlight was that I was only describing to you the decoder only architecture, which is used in the GPT variants of transformer. And one reason was that we didn't have a lot of time. And another reason was that if you are able to get something from the decoder only variant of transformer, maybe you can learn about the encoder decoder variant in your own time as well. But the concepts are going to be very similar. And if you are interested, these are some of the references. Specifically, the second course from Stanford University is a very good course if anyone is interested in diving deep into transformers or natural language processing with deep learning. So with this, I am going to stop this particular session. We are going to have a few questions about this particular session. In the meantime, I will ask the next student presenter to come over here and set up her, to make sure that her setup is ready. Zena. So, yeah, I will do it. So, do you want to do from here or laptop? Yeah. So while she is setting up, any question about the transformer?
Yeah, I have a question.
Sure.
At what point does personal cookies dictate the attributes of what you're trying to accomplish with the predictive model?
Yeah, so,
Or is it at all?
so it is at a very application layer. So what I was describing was the core. At the top of it, there are additional pieces that are added to the context. So whatever I was providing was assuming that there are no cookies, no personal information involved. But that personal information can be provided as part of the context, and then that can be used later on. So to answer your question, it is at the application layer. I was describing the architecture slightly at the lower layers.
Not at all.
Yep. Right. Any other question? Sorry. Yeah.
So as a user of AI, like ChatGPT or whatever, when I input some problem, how safe is my data?
In a way, it's hard to tell. It depends upon the companies, and these companies have been using a lot of users' data for their training purposes. Some companies are more upfront that they tell you whether they are going to be using your data for training purposes or not, but I think it's a bad thing in the industry right now that I don't see many companies complying with a lot of things that used to be considered sort of untouchables, that they are not going to be using a lot of public data. For example, we have seen some scandals that some companies have been using pirated books data as well, some other things as well. So it's really hard to say. It depends on company's policy and company to company.
What is the expectation of, for lack of a better word, an AI engineer to be hired? What is the expectation in terms of understanding concepts and applicability of it? I'm not very generic, but just to level set the entry level student.
So I work at Amazon as an applied scientist. So if I am conducting an interview, maybe at a mid-level, I will simply ask the person to explain the architecture of transformers. So I will expect him or her to know these details very well. So.
You have to show demonstration of applying this architecture to a concept?
Actually, if you know the details, then you can apply it in different way. So first thing is having the knowledge of these things. Yeah. So if he can show the capability or previous experience that he has been using them, that would be a really plus point. Yeah. So with this, I will hand it over to Zainab. So Zainab has been a student. So she is a high schooler right now, but she won the Alameda County Science and Engineering Fair Award last year, right? Yeah, and she has been working very hard on AI-related concepts. So I will hand it over to Zainab to describe her background and her project as well. And I want the audience to learn from the experience of these students so that they can inspire other students in our community as well. So over to you. Sorry.
What is the purpose for GPT to use the predictive model? So for example, Google, when you go to search, you want to know, you want the options for it to predict what you're going to say. But for GPT, you're asking very specific things.
Actually, as more and more data was added and these models became more sophisticated, either by adding more layers and other stuff, one thing that happened that everything became like an input and response pair. In other words, we can reframe every question like an input, and we can ask the LLM to describe the response as output. So that was like a paradigm shift, that instead of having sophisticated model, which you can have in many cases right now, you are going to frame your question like a question, frame your problem like a question or an English question, and then you are going to be expecting a response from the LLM. So right now everything is a prompt or input to the LLM, and then the response is going to have the output. Just like previously we used to have specialized model, now we will have to parse the response from the LLM to get the output. Yeah.
What's the public Wi-Fi? Yeah, it's not connecting. Because it's cloud, so I don't have like the app. That's the problem. I can use my hotspot. The presentations run on cloud, so I would need to get Wi-Fi to present. I mean, yeah, but I can't present. Oh, there, I think it's working now. Connect. Yes, okay. It should work now. Awesome. Yeah, so hey everyone, my name is Zainab. I go to Mountain House High School in Mountain House, California. And yeah, I'm a passionate student researcher. Ever since I was 12 years old, I've been really interested in science and technology, and I've been programming since I was like 6 years old. So like I have a huge passion for like STEM and everything, and I've always wanted to make an impact. So I started my first research when I was 12 years old, and this is a continuation of my research project. Just to know a little bit about me, yes, that's true. Yeah, I won the Alameda County Science Engineering Fair Engineering Grand Award last year in 2024 as an out-of-county student. And then this year I was an ISEF International Science and Engineering Fair qualifier. Couldn't go, but was a qualifier. And then I was also a Junior Science and Humanities Symposium semifinalist with the same project. So let's talk more about my project. It's called SECI, which is basically short for Social Emotional Communication AI. And what it aims to do is that it has two algorithms in which you can detect certain symptoms of neurodivergent or autistic folks into overcoming social situations. So over 75 million people around the world actually have autism, and social anxiety is the third most common mental health condition. And a symptom, a cause of social anxiety is the idea that there's dysregulated emotions. So last year my research really talked a lot about how dysregulated emotions and how to use machine learning to process those emotions and in real time help regulate them. So, and I researched further and I found out that neurodivergent individuals actually experience more stress when it comes to social situations. So how can we help them further using more physiological based signals? So that's what I really want to look at. And as you can see here, this was one of my main sources of inspiration, is seeing this trend here. I think this trend was an indicator that neurodivergent individuals need extra help. So for context, I'm a biology fanatic. Like, I love anything biology related. So I was researching and I found out that the muscle in our body that's most influenced by stress is your rectus abdominis muscles. So think about that for your autistic folks, right? They would feel it more severe. So how can I use something called surface electromyography signals to detect that in using a machine learning model? So this is my research journey, and obviously, in any machine learning task, you want to have your data first. You want to have something to train on, right? So I found data sets relevant to the task. For example, for sentiment detection, because as I said, emotions are extremely important when it comes to dysregulated, when it comes to social anxiety and autism, and then stress detection from these EMG signals, and then actually denoising input data. Oftentimes, past researchers skip over the idea of denoising input data, which is really important if you want good accuracy of models, and then training the models. So as Dr. Reza already mentioned, that recurrent neural networks had a shortcoming, which was the idea that it couldn't have long-term memory. So I decided to use a long, short-term memory recurrent neural network for text sentiment detection, and then having a supervised learning ensemble for stress detection. And then I analyzed them, but this is the data sets and hardware and libraries used. If you guys have any questions at the end, I can answer them, but I'm going to get ahead. So this is the edge deployment. I think one thing that really made my project stand out was that not only did I create 2 algorithms, I deployed them on edge devices, meaning devices that are less than $50 and can actually be used in real time. So I don't have the device with me right now, but this was a demonstration from my research paper that shows basically that you have a live input of either your muscle recordings and your voice recording, which will get transcribed to text using a transcriber model, which would be the VOSC API. And then the REST API server would send the EMG outputs of your stress and from the this computing board, and basically in real time you have a connection support for neurodivergent individuals. So yeah, that's basically all I have for my research project. I can show you guys how these models work right now. I can't give a real-time demonstration, but I can show you guys how it works. So when you want to evaluate a machine learning model, you want to make sure you can evaluate it visually. Sure, you have the numbers and everything, but how can you show it to the audience that, hey, this is a good model? So this was my model, and basically the EMG model that can detect stress and muscle signals can take a label output of 0, which is baseline nothing, 1, which is stress, 2, amusement, and 3, meditation. So you can see how specific the data is. And this was online data, meaning the beauty of research and machine learning is that you can get data from anywhere on the internet, and that's really important when it comes to open source research. So this is how it looks like. And then, like I told you, I had a specific method to denoise my signals for EMG especially, which was actually 500 to 600% better than the recommended dB level for denoising the signal, which basically means that my algorithm to denoise EMG signals is better than the industry level standard, as well as my text sentiment detection model. So this is how this would look like for denoising. I would use a bunch of electrical engineering methods, but I think one thing I really love about machine learning is you can combine so many fields together and make an impact. And then this is my LSTM model, where basically you can add any sort of sentence, and like how we mentioned before, you can give a list of tokens or even a list of sentences, and you can put it into a model, and you would get a sentiment out of it. So, like I said, the machine learning model only usually understands numbers. They can't understand natural language by itself. So therefore, if you see here, 0 equals sad, 1 equals joy, 2 equals love, and it's ongoing. So you can see here, Twitter is down. Oh, I think that's I guess we can all agree that's angry, right? So that would be a 3, and that's what my model predicts. I love this. I mean, I think it'll be joy. I mean, it can be labeled too, but I kind of see it as joy. So that's what my model also predicted. And then ... I think we all have those moments in life where we're just angry, so we just reply with a ... That's also really important. And then, yeah, I'm so angry, oh my God, yeah, 3. So that really shows how my model is accurate. And my model did achieve a 99.17% training accuracy and a 90% validation accuracy. So these are just a bunch of metrics you do when you're evaluating a model. And then, yeah, same for my EMG model. I achieved near perfect metrics on a type of algorithm that doesn't take a lot of time to. So one thing about machine learning, especially about transformers, is that taking a lot of data, when you're feeding a lot of data, it takes a lot of time. Computers are also they work, they tire and everything. So you have to make sure that you can find an algorithm that uses the less resources as possible, which I use. So it was really cost effective, accurate, and it was relevant to the task. So thank you so much. Yeah, if you have any questions, let me know. Yeah, I did my own untrained weights. I went crazy and I just did my own model. But for embeddings, I use Roberta embeddings. It's a transformer type embeddings to. Here we go. I did Roberta embeddings as it's like a type of LLM. If you want to, not really an LLM, but it's an embedding model to generate embeddings to summarize the sort of feature representations in your text data set. Yeah, I think what I'd recommend if you want to get started with machine learning, start with the open source resources. I think the internet has so much to offer you. You can really use a bunch of resources, like the Stanford lectures are really helpful. If you don't even know computer science, I wouldn't recommend diving deep into AI first. I'd recommend learning computer science itself first. Harvard CS50 is a really great course. I did that when I was in 6th grade, and it was really amazing. I loved the teacher and everything. So I recommend learning computer science first and then doing open source.
Any other question?
Do you think you have benefited more from single shot or multiple shot training? I know you were doing your own weights, but did you see, was there an impact if you were giving it prompts which included some examples?
Do you mean the training or the testing and validation?
The testing and validation part.
Testing and validation, yeah. This was just one example I decided to give to the crowd. But yes, I did do multiple iterations of testing and validation. In fact, in my previous project, I actually tested my innovation on autistic individuals, and they showed a positive response to my algorithms. So yeah, definitely, yeah. I think it's scientific research. You have to test it multiple times to make sure it's accurate.
Sounds good, thanks.
Any other question? Okay, thank you, Zena. So next panelist or next student demo over here is going to be by Azan. Azan is just entering high school over here, and he also won first prize in his category in Alameda County Science and Engineering Fair last year. So over to you, Azan.
Assalamu alaikum everyone. My name is Azan. I'm 14 years old, and this coming Wednesday I'll be starting my high school career at the Quarry Lane School. I'm really enthusiastic about STEM, machine learning, computer science, and especially robotics. Ever since a young age, since I was introduced to Transformers, I have had a very deep passion for robotics, and I want to make the world a better place through my use of robotics and computer science. So without further ado, I'm very excited to share with you guys my project that I've been working on that I took to Alameda County Science and Engineering Fair. This is Vision Assist, a revolutionary piece of technology that aims to assist people with vision impairments through AI. So as I mentioned earlier, last year I participated in the Alameda County Science and Engineering Fair and I won first place. From there, I was nominated for the Thermo Fisher Junior Innovators Challenge, and the results of those will be coming in the first week of September. I also won first place at the STEM for All competition. Here's some background information about the specific target demographic that I aim to assist with my project. So the World Health Organization estimates that 43 million people internationally classify as having visual impairments. This was in 2022, so 5 years back. Of those 43 million people, 16 million Americans have severe to total blindness. And these people face significant challenges in their day-to-day life, especially in academia and professional settings. This is obviously because the majority of literary materials are in mediums that aren't easily usable for them. For instance, a blind person will not be able to read literature in a textbook or script like we do. The Braille format was invented to overcome this challenge, but it has a lot of drawbacks of its own. It's very expensive and not readily accessible. Braille devices at the same time, once again, are very, very expensive and don't support multi-formats. So I asked, can the accessibility to the literary medium be improved for the visually impaired people through technology? And I wanted to create an AI-based system that accurately converts any given image with textual or mathematical data into both Braille and audio mediums. I wanted this to be accurate and have near real-time results, and this should ultimately improve existing systems and the accessibility. Here's a top-level description of the steps I have in my system. The first step is image capture, so this is where the user would upload or take a photo of the desired input. My system then performs OCR, optical character recognition, upon that text or upon that image and extracts that text. The user is then presented with a choice where they can either have that extracted text converted to audio or Braille, depending on the situation. Over here on the right-hand side, you can see a screenshot of my UI that I will demonstrate later on as well, and that also has the respective steps. So diving deeper into those steps, the first step is to capture or load the image. So in my user interface, I have a Python module that allows the user to either take an image via their system's camera, or they can also upload an image from their device. The second step is where the optical character recognition comes into play, and I implemented an OCR model called Paddle Paddle, and this Paddle Paddle is used by a lot of corporate companies and even some government agencies. Paddle Paddle provided very good accuracy across multiple scenarios, meaning that it was the best choice for my system. But I didn't just stop there. I also fine-tuned hyperparameters for different phases of the OCR pipeline. For instance, I increased the bounding box size, and I also changed the base model from version 4 to version 3, and this was because version 3 was more specialized towards textual images, which was my target. I also implemented spell check as an additional post-processing to ensure there are no minor errors. On the left-hand side, you can see the streamline of the OCR pipeline. So this is where the user is presented with two choices. They can either have the extracted text given to them in an audio format. So for this, I implemented a text-to-speech functionality within the Google text-to-speech library, and that converts the extracted text from OCR into audio. Or the user can send the extracted text to my hardware, my Arduino system, that implements a custom program to retrieve input data from the computer and transmit it to the Arduino via serial port communication. Another custom program on the Arduino converts input data to Braille format by encoding the input data to Braille formats. Here's a quick demonstration of what my system looks like and how it works. So here I am uploading the Arduino sketch. This is everything that revolves around the hardware. This is my Python user interface that I created. So that's my user interface, and I will now upload an image of the word hello. I then proceed to translate that into Braille. I send it over to Arduino, and that's where my Braille system outputs the given word. So how did I evaluate all this? So I first created a custom program to convert text into textual images. I basically synthetically generated my data in both textual and mathematical formats. So I got my textual data from Project Gutenberg, which is a website that has AI stories for children. And I also had mathematical data in both printed and handwritten formats to ensure there are no niche inputs that crashes my system. I also used publicly available data as a cherry on top. I got English characters dataset from Kaggle. You can see what that looks like. I used commonly use metrics in the field of WER and CER, word error rate and character error rate. So these are my top level results. My system averages a WER of 7% and a CER of 3.1%, meaning I have a word accuracy rate of 93% and a character accuracy rate of 97%. One thing to note on this slide is that I wanted to have my system convert those textual data images accurately, and I analyzed that using a Python program, as I mentioned earlier, to calculate both WER and CER. I also wanted the system to output the information within real time, and my system averages a processing time of 1 second per 500 characters, which is very close to real time. So the main thing in this system was my comparison of my model against other approaches and models. So first of all, we have Tesseract, which is a frequently used OCR model within corporate agencies. So for WER, my system, in handwriting specifically and printed, averages of about 68%, and it is better by 68% overall than Tesseract and WER, and it is around 20% better in both mathematical formats. Vision Assist is slightly less accurate than Tesseract for text. However, it is such a small difference that it does not make a very big impact. I also compared my system against OpenAI's ChatGPT version 4. So as you can see here, my system outperforms ChatGPT for mathematical data in both WER and CER. However, my system is slightly less accurate than ChatGPT for text, but once again, it is a smaller difference, so it does not make a huge impact. One thing to note is that ChatGPT has almost 3 times more latency on average as compared to Vision Assist. Going back to one of my goals, I wanted my system to have real-time output, and ChatGPT is basically unusable in most scenarios. So all in all, Vision Assist is a proof of concept that shows how AI can transform the lives of the visually impaired. It is a learning assistant for the visually impaired to better understand educational content. They can also learn Braille with this. I want to continue working on this, such as hardware enhancements to have a full-fledged reader, fine-tuning the optical character recognition even further, and moving all of this to embedded modules. Thank you so much.
Any questions?
I didn't quite understand, you said the Arduino module, that's like a physical touch system? Is that
Yeah.
what that is?
Yeah, so I created a physical touch system. So from my system, you give the Arduino the information, and it pops up in Braille.
Okay.
Any other questions?
Great job, Azan. MashaAllah.
Thank you, Mr. Mujahid.
What's your plan for the next? Because you're thinking that this is going to be for the system for visually impaired people, and then you have a dependency that somebody need to upload an image for your process. So what are your thoughts around that?
Yeah, so obviously this was just a proof of concept to show that there can be similar iterations to this, that this can exist in the real world and make a real impact. Obviously that is one of the niche things about this project, and I was taking that into account, and within the next versions I'll be combating that.
Good job, mashallah.
Any other questions? Okay, thank you, Zan. Yeah. So now we are going to have some really interesting demos from Sami. So so as you can see on the screen that these are really state-of-the-art sort of the things and very recent things that Sami is going to be demonstrating. And I think that I will like Sami to introduce himself because it is a really hard thing for me. Sami is like a very talented, capable guy. He has been working in the machine learning industry for long, and I know him through various sources. And I think that whenever I talk to him, I learn a lot about machine learning, and I hope that that is going to be the case for the audience as well. So over to you, Sami.
I think Raza was way too kind. I learned a lot more from Raza than he does from me. How does this work? I'll just hold it. So, like Raza said, I'm Sami. So in terms of background, I've been working or engaged with AI for, I would say, about 15 plus years. My first job was actually a student job in Germany, working at the German Research Center for Artificial Intelligence in 2009, very long time back. And I was working at the time on planning algorithms for robotics. Then I did a PhD in machine learning in the Netherlands. And then after that, I've been working in industry for about 10 years. And I'll not bore you with the details because let's spend time on the actual demo, which is interesting stuff. So the students did a really great job, right, of demos that I hope wowed you a lot. I have something much more pared down in comparison, but something that I was hoping would allow you guys to get a sense of how to use AI today if you are just going on ChatGPT or Claude or using any other tool. How does that process actually look like? What would you, how could you maximize the productivity and value you get out of existing tools? And because I'm preaching to the choir, right? If I'm telling you guys that I want you to use it, it would behoove me to use it myself, right? So which is why I have practically mostly used AI to generate most of the content that you see here, right? Starting from this first slide, where I'm going to tell you about how, so this slide has been generated using Claude Anthropic, right? And in this slide, I'm basically indicating what are the uses of AI I'm going to talk about, right? So I'll first talk about ChatGPT deep research, right? Which is something that came out of ChatGPT, I think, in September 2024. And that allows you to, given a certain topic, you can tell ChatGPT to generate a deep research report on that subject and, include all sources and really give you a bigger picture with details on that specific subject.
Sorry, there is something wrong with this particular display, so maybe some people want to move a little bit back for better view. Sorry about that.
So that's deep research, right? Secondly, what I want to do in this demo is actually build on top of what I've, yeah, of course.
We are thinking that if we reconnect it back,
Uh-huh.
it might help.
Okay.
The Mac.
Yeah.
So probably you better use this one to connect.
Maybe you should use directly out. Just remove this. We don't need this, right? Okay. So like I said, I wanted to make it such that I start with deep research, right? And I'm going to mostly be working with English language prompts, which is something that all of you guys in the audience can do, right? So I thought that I would start with the use case that I have to demo to you guys, right? So I want AI to help me figure out how to demo to you guys, right? So that's where I first start with asking ChatGPT deep research to generate a report of all the greatest and latest AI use cases that I can demo at the MCC. So ChatGPT deep research will generate this report, right? I will show this in a few minutes. Then what I will do is I will take this information from ChatGPT deep research, which is generated as a PDF, and I will upload it into Claude, right? In Anthropic Claude is a different model. And I'll ask Claude to generate a set of slides that I can show you guys, but because in this particular presentation, you cannot read a 10-page report, right? So then we'll generate the slides, right? The slides will get generated in HTML format, right? Which is like basically a web page. I will upload that web page back into ChatGPT agent, which is a separate release from ChatGPT, I think maybe perhaps a few months back, like 6 months back maybe. And I'll ask ChatGPT, hey, these are all of the use cases that I would like to demo to the audience. I want you to be able to generate a video showcasing all of these use cases, right? And show how these use cases, AI can generate these use cases, right? After that, we'll take a short break to look at Gemini VO3, which is the latest model from Google, where you can create really stunning 8-second videos on any topic based on a prompt, right? So we will see an example of that. And if we get time, which I don't think we will, I will go into a Gemini CLI demo in the end, which is actually a code line, a command line interface tool. That's more for more engineering style or technical audience amongst you guys, where you can actually talk to Gemini CLI and say, you know, in this case, what I will do is that I'll take the same HTML, put it in a folder, right? And I'll say, hey, I have these use cases. I want you to go through each one by one and help me create applications that I can show to the audience to demonstrate how these use cases work, right? So still with me because we're going to go for a ride. Okay, awesome. Let's start with, so this is the very first thing I started with, right? After I'd done all of this work, I went to Ali Bhai yesterday and I said, hey, I want to do this tomorrow. Can I show the demo, show what I'm going to show to you? And he said, this all looks good, but the audience isn't going to be able to follow you. So first generate this one slide, which I just showed you, to be able to explain what you're going to do, right? So I said, okay, after having done all of this, I then basically told Anthropic Claude that, hey, I'm going to be giving a talk at the MCC East Bay about AI. I will demo practical uses of AI tools to the audience that would show them the power of using AI in everyday work, right? And I plan to show them the following, and all the stuff that I told you. I want you to create a single slide that illustrates this. Keep the style template professional. Remember, you're an expert at creating slides. I typically tend to say you're a McKinsey expert because McKinsey people are the best at creating slides. But in this case, I skipped. But you can see that this is the same one. The slide that I was showing you is the one it generated, right, on its own, right? And here I do want to make this point that it's really important to also understand which tools you're using in your everyday work. For example, if I gave the same prompt to Gemini or to ChatGPT, they would not call an HTML coding tool to respond. ChatGPT will also create something in text, or maybe it will call an image generator. And those image generators are not that good at creating slides. And then Gemini will probably just generate text and say, I cannot do this work for you, and maybe you can use this text to copy into a slide. But here what Claude has done is that it has taken all the text, and it has generated HTML that shows this beautiful slide to you, right? So that's the first use case, right? And remember, I told you that I'm going to start with talking to Deep Research Agent. And this is the only thing I told it. I'm going to be giving a talk at the MCC East Bay about AI. I want to demo practical use cases, uses of AI tools, and so on. Show me the easiest and most impactful uses for AI and agent that I could share with them. Right, so it said a bunch of stuff. It worked for, this usually takes about 15-20 minutes, right? That's the Deep Research Agent that is being used here. And this is all, by the way, anything I show here is just $20 per month, right? This is not the $200 per month more expensive personal version, right? So this is the prompt I gave it. This is what I got back, right? This is the downloadable PDF, right? That ChatGPT generates that in a it indicates this. I have generated this in a 15-minute talk. You can demonstrate this, and this, right? And this is, you can see there's a bunch of stuff in here. We are not going to go into all of the details, along with all the sources, right, on where it's coming up with the information that it's coming up with, right? And since I cannot show this to you guys, right, I cannot demonstrate to you that this is actually valuable, I then put this back into Claude and I said, hey, here's a PDF. I need to show slides to the audience. That shows what I'm going to be talking about. But now you're going to be generating slides based on this PDF that I uploaded. Don't just make stuff up, right? And it generates slides, right? So now you can see that these slides, based on the prompt that I gave, shows what are the practical AI tools and use cases, right? Demonstrating how modern AI tools boost everyday productivity. And it's talking about the same thing. That it's going to use ChatGPT, Claude, Gemini, and maybe it's given an example for Replit as well. And it's starts with saying that you can use AI for writing and communication, right? That's obvious. Email and document drafting, you can use it for summarization, right? Gemini already uses that, is already used in Gmail to be able to do this. And then you can also use it to do smart task management. I don't know how good a use case that is, but it's at least one that it's indicating. Then it's talking about how you can use it as a research assistant, right? Explain blockchain like I'm 5 years old. What are the pros and cons of remote work, right? And then you can use it for document analysis, where you give it hundreds of pages of documents into ChatGPT and be able to get a summary of it, or be able to ask questions over it. And then if you have an issue with a leaky boiler, for example, in your garage, then you can use it to ask questions about it. By taking a picture and ask it what's going on. So that's, did I skip a few slides? Yeah, I did. So then you can use it for pair programming, right? You can use it for developing an application. Last time, if you remember, in February, we used Replit's agent to be able to generate web applications, right, for different use cases. So that's what it's suggesting here. And it's funnily enough, I didn't ask it to say anything about Claude, but here it inserted, because it's Anthropic's model, it says actually Anthropic Claude 4 has been benchmarked as the best coding model of 2025, and it inserted it without being asked to, right, which is a bit hilarious, but apparently Anthropic's model wanted to add that detail. And then you can see that there's something about multi-step task execution. I'll skip the details here. Visual content generation, brainstorming partners. And then, yeah, these are all, obviously my larger meta point here is that these are slides generated by Claude, right, based on a PDF web that we uploaded into it, right? So we are done here, right? I wanted to show you guys that these slides can be generated. Now, what did I do next? What I did next was I took this HTML and I put it back into ChatGPT, but this time I used the agent tool. All of the stuff that I'm talking about is if you look at the plus icon inside ChatGPT, there are different things you could do. Sometimes you can use the plus icon to do deep research. It shows up, right? And then sometimes you can call the ChatGPT agent, right? So in this case, I called the ChatGPT agent, and I said, again, the same story. I have compiled the easiest, now I'm telling it, I've given you all of the use cases, right? They're in the attached HTML. I want you to replicate as many of the use cases as you can and show how they could practically be done. And now again, I'm going to demonstrate something powerful about these systems as they exist today. I told it, save all of your work in a downloadable video format that I can share with the audience, right? And make each use case as detailed as possible. You can take as much time as you want and make the video as long as you would like to, right? And at this point, give me a moment while I pull up the screen recording. So this is going to be the agent working, right? I'm going to skip over. I'm not going to show everything, right? You can see the agent is being called, and it's going to set up a desktop. And you can see that in the desktop, it has opened the HTML file content, right? And it's parsing through all of the HTML file content as it works through it, right? And as it works through it, it's telling you, hey, I'm looking to replicate all of this work. I'll check the content. I'll see what you have, what you're asking me to work on, right? I'll just skip in the intro. You can see that after it has parsed through the content, it is going through the sources as well, right? We had sources in there. Those sources were at the end of the slides. Those sources it's looking up, right? And based on those sources, it's coming up with certain use cases that it needs to demonstrate. And one of the use cases was to create logos, right? And you can see it has generated a logo for us to be able to see in a downloadable video, which I will show you. That output is not shown here. This is the agent in its working while it's working towards the goal, right? Which I gave it, that you have to give me a downloadable video. So it continues to do that work. I will not bore you with the details, but in the end, it gives you, a downloadable video. And now I'm going to show you the downloadable video. It's not this. This is the agent in its working while it's working towards the goal, right? Which I gave it, that you have to give me a downloadable video. So it continues to do that work. I will not bore you with the details, but in the end, it gives you a downloadable video. And now I'm going to show you the downloadable video. It's not this. This is the agent in its working while it's working towards the goal, right? Which I gave it, that you have to give me a downloadable video. So it continues to do that work. That's for the next demo. The downloadable video is here, where it has taken each of the different use cases that we just saw, right? Email drafting is the first one, right? And it shows you, hey, draft a polite email about a project update. And it's showing an example AI response, right? And then summarize the key points from the article. Remember we said that summarization is a use case? Summarize the key points from the article, 37 ways to use ChatGPT, right? And it's come up with the summarization. Similarly, it has come up with various other, explain like I'm 5, explain quantum computing like I'm 5-year-old, and it's come up with an AI response to explain that, right? And what is the current weather in Pleasanton, California? I ran this yesterday afternoon at 2:25 p.m. and you can see the Pleasant, California, it's 72 degrees Fahrenheit, and so on. Generate a Python script that reads a CSV and outputs summary statistics. That you can see that here. Then there are expense tracker app. You'll see a version of this later. Brainstorming ideas, and then generate a modern minimalistic logo for a cafe. Right, and it's also generated an example of that. You can see like what I just want to make you guys realize that all I've done so far is told different tools that I'm going to be giving a talk, and I want to show use cases. Right, I started with ChatGPT Deep Research. It generated a PDF with all the use cases. I put that into Claude, asked it to generate a set of slides, what it generated, and I showed those to you guys. I took those same HTML slides, put them back into ChatGPT agent, asked it to generate a downloadable video that I can show you guys, and it generated it, right? And I've literally not done much work at this point, right? And then basically, we're through with our first 3 use cases, right? At this point, I want to take you guys back to this one use case, which is not related to one of the use cases there in the ones that we saw, but is just a cool example of what AI, latest AI models are able to do, right? So that we will end with this 8-second video of the kind of models that you're able to, the kind of videos you're able to generate these days with the latest, coolest models, right? This is a prompt where we told it that we want to see a starry night with shooting stars, right? And you will hear audio, and you will hear shooting stars go by. And this is generated using Gemini. That brings me to the end of the demo. I wanted to show you guys something else, but we are out of time. If you guys are interested, we can do a follow-up after the Isha Namaz. We can look at the last demo and then do some Q&A.
You weren't required a plugin for that? You didn't have to include a plugin to create that video? That was straight from GPT?
That's straight from Gemini, right?
And this is only based on prompt, right?
This is all prompting. I'm just a regular guy writing English, right?
Yeah. So maybe we are going to have the final demo right after the Isha prayer, if it is okay with everyone, and we can have a QA session afterwards as well.